If you've ever cracked open a phone, a computer, or even a toaster, you've probably seen it. That distinct green board with copper traces, tiny chips, and soldered components. But here's the thing. Why green? Why aren't circuit boards blue, black, or gray by default? Is it just tradition, or is there something deeper going on? It turns out the answer is way more technical and more interesting than you might think. By the end of this video, you'll never look at a green PCB the same way again. Let's start with what you're actually seeing. That green surface on the board, it's not the board itself. It's called a solder mask. The real circuits, those thin copper pathways, are just below that layer. And the solder mask, its job is to protect them. It stops solder from bridging across traces, prevents corrosion, and keeps the circuit stable over time. So really, the green part isn't for electricity, it's for protection. And now the real question becomes, why is the solder mask green? To answer that, we need to rewind to the early days of electronics manufacturing, around the 1950s and 60s. At the time, manufacturers were developing new ways to mass-produce circuit boards. They needed something tough, stable, and cheap to protect the copper traces. They turned to epoxy resin, a thermosetting plastic with great chemical and heat resistance. And one of the earliest versions of that resin came with a green pigment by default. That pigment, usually chromium oxide, was already used in industrial coatings. It was cheap, durable, UV stable, and chemically compatible with the resin. So green became the standard, not because it was chosen for style, but because it just worked. But chemistry wasn't the only reason green stuck. There was a human factor too. When technicians inspect circuit boards, they need to see fine details, tiny solder joints, hairline cracks, or missing components. And it turns out green provides one of the best contrasts under bright light. Black looks sleek, but it hides details. White scatters too much light. Green, it's easy on the eyes and gives strong contrast against both copper and white silkscreen labels. Think of it like reading black ink on white paper. Low eye strain, high visibility. When your factory workers are inspecting hundreds of boards a day, that matters. Now here's where things get even more interesting. Solder masks also need to handle heat, UV light, and even infrared scans. Green epoxy turned out to be very stable under reflow temperatures, the high heat used to solder components. It also reflects light at wavelengths that help with automated optical inspection systems. These systems use cameras and lighting to scan boards for defects, so clarity and reflectivity matter. So even beyond visibility for humans, green worked well for machines too. It wasn't flashy, but it was reliable. Now imagine this. You're a factory that builds 10,000 boards a week. Your whole inspection setup, cameras, lighting, training, is optimized for green. Are you going to switch to red or blue just because it looks cooler? Probably not. The industry settled on green. Machines, tools, and even operator habits were all built around that color. And once standardization takes hold in an industry, inertia sets in. Any change introduces risk. So unless there's a really good reason to shift, green stays. Of course, not every PCB is green. Gaming motherboards, custom keyboards, Raspberry Pi clones. You've probably seen boards in black, red, blue, even white or purple. So what gives? Most of those color choices come down to branding and aesthetics. They help a product stand out on a shelf or match a color scheme. But they're not always better. Black masks make inspection harder and retain more heat. White masks reflect too much light and can confuse vision systems. Red and blue work okay, but sometimes reduce contrast or wear faster under UV. So while they might look cool, they're often reserved for low-volume or enthusiast products, where aesthetics matter more than manufacturing efficiency. Modern solder masks are far more advanced than their 1960s ancestors. Today, we use photo-imageable solder masks, materials that harden under UV light in precise patterns. This allows for much tighter trace spacing and higher density circuit layouts. But here's the kicker. Even these modern materials can be made green, on purpose, so they remain compatible with existing workflows and visual inspection systems. So even the new stuff looks like the old stuff. Why are circuit boards green? Not because it's stylish, not because it's random, but because green solder masks offered the perfect blend of cost, performance, visibility, and reliability. It wasn't a fashion choice. It was a functional decision. One that stuck for decades and still works today. So the next time you peek inside a gadget, take a moment. That green board isn't just there by chance. It's the result of engineering decisions, material science, and a little bit of human ergonomics, all baked into a single color. And now, when you see green, you'll know why.